So hi, my name is Itay, and I'm here with Maria, and we are going to talk about temporal in Checkr. Okay, so as I said, I'm Itay, I'm a senior software engineer, and Maria is a staff software engineer in Checkr. And this is how what we're going to talk. We're going to see how a background check unfolds, what are the challenges, how we are using temporal, some use cases, future plans. Hopefully it will be fun. So first, what does Checkr do? Checkr does background checks. Background checks are the process that someone needs to go before they can go into and work, let's say for Uber or Lyft or whatever company. They need to make sure that the person can actually work for them. So a background check starts with a collection of PII, which means private identified information, like let's say social security numbers, addresses, phone, all this stuff. It runs screenings based on this data by using external vendors that they give them some of the PII and then return us the result of the screening. For example, for MVR record, motor vehicle record, to see if there are any citations for the person that we're running the screening on. And we produce a report. A report is essentially a list of screening results. So that's the base terms that you need to understand in order to know what Checkr does. And okay, so this is kind of how we used to do it, a little bit of how we used to do now. You can see that it's a bit look like messed up. There are really like bespoke state machines and various weird definitions and processes for each check, and each screening can actually reach out to the internal details of other screenings. This is actually natural and happens in every company that starts and then grows big, because initially you're just going for the wins. You're doing the stuff that is the most faster to do in order to get the better bang of the bank, so you can continue living. And then when you have one success, now you're mired in technical debt and you need to eat your own spaghetti or dog food. So this is stuff that we've been trying to solve for a long time. The challenge is that we have inefficient product development due to tech debt. Now that everything is such a spaghetti, it's really hard to reason about and to know how to implement new stuff without breaking old stuff. There is no crisp model for how skin behaves, not enough separation of concerns. Complex scenarios are really hard to deal with because there are a lot of nuances that the background check needs to comply with. And basically lack of formal definition and pool boundaries lead to lack of clarity, which I think we can sympathize with that. That leaves us looking like this. This is very cute, but this is not fun. So we needed changes. So faster time to value, we needed to define, and that's the most important thing, I think, crisp interfaces between components. We need to be able to compose different orders, like different ways we run screenings on the fly based on customer demand. And we needed to have a compliant storage for data that we gather, like PII and screening results. We needed better tooling and much easier way to test it. So this is the model that we moved to. You see that it's much less spaghettified and it's more layered. And Zoom bothers me in a moment, that's it. And what we are doing essentially, we're moving to the layers model. So we have external vendors, we have screenings that, let's use where is it? Where is the laser tool? Oh, there you go. Now that's better. We have external vendors. We have screenings that talk to the external vendors. And we have some new model that we call screening orchestration that knows which screenings to call at what order. Sometimes screenings depend on other screening, for example. Other than that, we have something that we less focus on, which is the order lifecycle, and then we talk to the customers. So we introduced Taskr. Taskr is the name of the execution mechanism that we're using in order to coordinate the screenings. We really like the letter R. We have a lot of components that have the letter R at the end, like Flagger and Taskr and Checkr. It kind of makes us sound like pirates. So what is Taskr? Taskr is a screening orchestration system. Taskr defines a strict task interface, which is the thing we needed the most. The task receives facts, emits facts, and operates based on some kind of configuration. Only data with schema, for example, a fact defined as a protobuf, can be given and received from a task. No arbitrary JSON flying around willy-nilly and stuff like that. So this is essentially how we model a task. How do we execute a task? So let's say we've got some kind of order and we want to run a screening. A screening is abstracted as a task. So what we do, we create some input facts. Facts are actually the atomic pieces of data that we're using and storing in our system that we can refer to later. Let's take a sip here. So we're storing the fact. After that, we're creating something that's called for our records a task record. A task record says, hey, we are having this task going to run. Let's keep an eye on it. Once the task record is created, we are using the Taskr service, and we're using this thing called Temporal, I believe you heard about it, to actually start the task worker. So a task is actually a temporal workflow and activities, but let's begin with the workflow. Once the workflow starts, it actually fetches the facts from the fact store and the task from the task store service and do its stuff. When it's done, it writes the data that the fact that it produces, mentioned in the task store, and updates with a Kafka message to the order in order that to run. Essentially, you don't need to understand all this to understand Checkr. Essentially, we abstract screenings as Taskr workflows. That's the main thing. Okay. Yeah. So we're essentially using temporal as the execution mechanism that is abstracted by Taskr. Taskr is also an abstraction layer above task execution. Task execution is delegated to temporal. Essentially, Taskr tailors temporal to Checkr's need. We have another layer of interface, which we call Taskr, that adapts temporal API to Checkr's API that is more convenient to people who develop neat screenings and stuff like that to develop them. Each task is implemented either as a workflow and activity. The only data that is allowed to be shared with a task are facts and configuration. This is enforced using temporal data converters. Now, temporal data converters are awesome. They enable us, and you'll see it in the demo later that Maria will show, to not supply any actual PII to temporal. Temporal never holds any information from Checkr other than pointers to facts and tasks. The Checkr will tell temporal, hey, this is the task ID, start the task, start the workflow about this, and when the workflow begins, it consumes the facts used by facts ID. We are using actually the data converter to convert between actual facts data and fact ID and the other way around. This is very useful if you haven't used data converters. So temporal server never see, as I said, actual encrypted data from Checkr. All PII is stored as facts, stored in a compliance store based on GDPR. I need to read this sentence. Each fact is stored in a key value content addressable store and have an associated fact ID. When temporal receives the request to start a workflow or an activity, only fact IDs are supplied. The data converters know how to acquire the real facts from the fact store using these IDs. This is how facts actually look like in our system. When we want actually to start to create a new fact that goes into the system, it must be defined in protobuf ahead of time. It's awesome because it's cross-claim compliant. We're using both Go and Ruby in Checkr, and everything is strictly defined up until what we can do. There are another layer of verification later, but that's the base idea. This is an example of when you're looking at the Temporal UI, you can see that it doesn't receive any actual information. It receives the task ID and returns effect ID. Temporal never sees anything concrete other than these pointers, which is awesome. So in Checkr, we have another thing that is kind of unique. I think we have two kinds of workflows. We have static and dynamic workflows. When running a specific screening, we know all the steps. Let's say when we're running a specific screening, we know ahead of time all the steps that need to be taken before the process even begins. For example, a common screening looks like this. We prepare some kind of data based on input facts, send it to the vendor, wait for a response from the vendor, annotate the data, and send the facts back to the order. Always the same flow. The workflow will always be the same. You could draw it out like a flow chart if you want to. A dynamic workflow, on the other end, is what happened in the screening orchestration. You can see the screening session as a dynamic workflow. We do not know ahead of time which exact screening are we going to run. For example, after we run SSN trace based on SSN number, we get a list of addresses. That's what SSN trace gives us. We only then know which states to run, let's say state criminal search on, or other reports that might be, other screening that might be needed. So we needed a way to do it dynamically, and Temporal actually gives us the best way to do it because we don't just go and draw the flow chart. We actually have some code that if any crash occurs can be even replayed in order to decide stuff on the fly and choose the next step. This is quite unique and we actually love this. Before we embarked on this adventure, we did some experimentation and modeling. So this is an ugly chart using dot format, using Dotty that can show, for example, that you don't need to understand all of this, but see the highly dynamic nature of our process, that we start with some kind of social security number, we're running some kind of SSN trace. We got SSN trace results, various facts, and based on the facts, we know to run, let's say, state criminal search, county criminal search, and stuff like that. Even when we don't have, let's say, in New Jersey, in Bergen County, we know something goes there, but we don't know exactly what, the workflow can decide, okay, run a county search on this county that we haven't done in the first place, and then we discover some, let's say, someone committed, let's say, a murder in Bergen County with this social security number. So that's very useful to have this kind of ability. Another special thing that I think not everybody undergone with Temporal is that we actually started with Cadence. When we started Taskr, Temporal was probably just a fever dream in Max's mind. Only Cadence was available, so we used that. When Temporal came to be, we already had a long-running task in production and we couldn't just make the switch. Let's say for international, we had long-running queries that can take months even, which is not that unusual. We couldn't just take it down and move to Temporal and restart it. We had to keep this running. The way we did it, we started in each screening service, we had only Cadence worker. What we did, we actually now start both Temporal and Cadence workers in each screening, in a way that old workflow can still run with the same code or even new code that I'll show how, and the Temporal worker can actually take all new workflows. So the same exact code is running both for Cadence and Temporal. How do we do that? Since we're using Taskr, we actually introduced another layer called Temporal Compact. What we did is actually we expose everything as in Temporal API using a Temporal SDK. Old workflows that were coded for Cadence moved to use the Temporal SDK, but what we did, we actually passed them a Cadence context with a custom of a temporal context. That way, when they actually access anything that needs to use Cadence, we actually move them to use Temporal behind the scenes. Sorry, the other way around. If something coded that looks at Temporal, but it's actually a long-running workflow with Cadence implementation, we actually use the Cadence SDK. It's a bit confusing, but it works great. So for example, execute local activity, because we are using this temporal compatibility layer. By the way, if anyone is interested to use such a thing, let me know, I might share the code. We do execute local activity, and if the actual context is actually a Cadence context, we're actually using Cadence to actually execute the local activity and return this as a temporal future, and it works great. For example, in a workflow handler, we actually calling a Taskr temporal workflow, this abstraction temporal. This will call tcompat under that, and will actually launch either Cadence or temporal based on on the context that is given here. This is quite cool. So we really love temporal. Thank you, temporal. This is awesome. Temporal hosts and manages temporal for us. So far, it's been pretty smooth. I see Ryland is smiling, which is awesome. He should smile. He has a lot of good reason to smile. And we are getting quick support. And yeah, awesome. Thank you.
We love you too, Itay. We love Checkr in general.
Yes, let's hug.
Yeah, thank you, Itay.
Okay.
Yeah, so I'm Maria. I'm on the Checkr's international team. So I would like to share some insights on how international screening works at Checkr using temporal. So yeah, as previously mentioned by Itay, running a background check is this multi-step process, and most of these steps can be easily visualized as like separate workflows defined across our ecosystem. But before that, before explaining how an international screening is defined at a very high level, I would like to share some insights on the current state of our platform. So next slide, please. Yeah. So our services are deployed in 2 different environments, US and, staging and production, and in 2 different regions, US and EU. Temporal is also hosted in 2 different regions for us, and this is mainly required for data privacy regulations that we need to comply, depending on the candidates that we're running the background checks for. So far we have defined 10 different workflows across different products, and we have defined a few common activities that are also used around different products. We have around 30,000 workflows executed in production at this moment in the past year and a half. And yep, we can go to the next slide, please. So yeah, all screenings at Checkr, not only international ones, can be now defined as a group of activities that are required to complete an investigation process, right? Let's say we're performing an international criminal search in the UK for John Doe. So as the input of this workflow, we're expecting candidates' personal information, and as an output, we expect records or no records. So it would depend on the type of search that we're running. We can be running criminal, education, employment searches, and depending on the type of search, we're going to expect criminal records, education, or yeah. These activities are meant to complete one specific step of the process with a well-defined input and output. So for example, if we take the first activity, which is going to be like create an order for the data vendor. This is going to be its own activity. As an input, we're going to have the candidate data that we need to send out to the vendor. And as an output, we expect always to be a vendor order ID that they created, so we can then externally refer to that order using that ID. So yeah, this activity in our case will definitely block the entire process of completing the screening and the background check. And this could take seconds, days, weeks, even months, depending on the search and the country that we're searching on. But yeah, once at this point, we just need to pause the workflow and wait for the data vendor to send us webhooks to notify us that they complete the order. So once we have this, we will resume the workflow. We'll start parsing the information that we got from them and notify different services in Checkr about screening completion. So sometimes it would be reaching out to internal teams for review, or notifying a screening completion to the customers or the report orchestration level. And also, for example, send billing information so we can now invoice the customer for these searches that we're running. Yeah, next slide, please. So yeah, at Checkr, we have implemented this customized UI for engineers to access workflow information. And this UI interacts directly with our Taskr platform. This is very useful for us. We can see the task ID, which we use as a reference across different services. We can also see the metadata, some logs. We can link each task to the executors page, which was previously Cadence, and now it's Temporal. So then we can see the details on the temporal side about each workflow and activity that we're executing under this task. But yeah, this is pretty helpful for us. If you see the task log records, we definitely check out like every single step of the process, and we can link into the activities themselves. So we can take an insight into the input, into the output of the activity, and make sure that things are, make sure that things are well defined and the task is behaving as it is expected. So if we click on a child task link, which is the little red circle, in the next slide, we're gonna see how the activity page will look like. So if we can go to next slide. Thank you. So yeah, this is the way an activity looks for us. It's the same structure. We're gonna see the input, the output. The task configuration will determine how this activity will behave. And this UI, it's mainly used for developers at the moment, but we plan to revisit its purpose in the future. So to see if we can extend this usage to other teams, internal teams at Checkr, mostly on the operations side. But yeah, just wanted to highlight that having this visibility to our workflow is pretty helpful for us. Next slide, please. Yeah, when it comes to celebrating our wins and our learnings, we definitely need to call out that we get multiple things when developing our products using Taskr with Temporal. So developer experience has been revamped when defining workflows across the platform. I think we believe that modeling our problems as temporal workflows have definitely helped to simplify our thinking process and development processes as well, and has also provided the workflow observability that we were previously missing. Before temporal workflows, like it was pretty hard. It took us a lot of engineering effort to understand how things were failing, how we were able to move things forward, because there was no visibility of these challenges at all. So this has definitely helped us. And of course, this transparency makes the debugging process easier for engineers. So as mentioned before, the activities required to run screening workflows are very similar for all different products at Checkr. So as a best practice, we have created this shared package that implements common activities and can now be included as part of any workflow defined with Taskr using Temporal. So activities like sending billing information, notifying other teams, or communication across services. So these interfaces are pretty clear now and are able to be shared across different teams and products, which is awesome. So yeah, this has been a great collaboration opportunity for us in the organization and has certainly improved the engineering productivity. So that said, if we go to the next slide. Thank you. We want to expand temporal usage for new teams to build new products. We also want to redesign that code that we developed a few years ago and moved out core workflows at Checkr to use Temporal now. Also encourage the creation and adoption of common workflows and activities, as well as extend the functionality that we have in our UI to enable engineering efficiency. So overall, our journey with Temporal and our Taskr wrapper that Itay went through has been great. It certainly facilitates the thinking process when it comes to implementing complex scenarios, using long-running and reliable workflows. And at the same time, it gives us the visibility that we were missing for some time. So it's definitely easier to know what's going on with our workflows and get some insights on it. So I think this is it. So thank you so much for your time. We would love to hear questions, comments, reactions, and yeah, we're hiring. So I think the next page, yeah, if you want to reach out to Itay or myself, we also have a link to the engineering page at Checkr, where you can find links to our blog post, the open roles. So yeah, it will be great to hear from you guys. Thank you.